Hey everyone, welcome to This Explainer. So if you've been hearing the term AI agent thrown around lately and kind of wondered what actually makes it different from, the standard chatbot you type into every single day, you are absolutely in the right place. We're going to completely deconstruct the anatomy of autonomy today, looking directly at the documentation from the platforms that are actually building this future. Here is our roadmap for this one. We'll start with the AI agent blueprint, then compare workflows to autonomous agents, break down the agent harness, explore the so-called USB-C of AI, and finally, wrap up by simulating human behavior. All right, let's jump right into part one, the AI agent blueprint. We really need to start with the missing link here, which is how an isolated language model actually gets the agency to interact with the world around it. Think about it. How does an AI actually take an action? By itself, a large language model is really just predicting the next word based on its training data. It's brilliant, sure, but it's totally trapped in a box. It can't look at your calendar, it definitely can't run a complex math calculation, and it's not going to execute a multi-step research project completely on its own. To do all of that, it needs a framework, something that grants it true agency. So when you look at leading frameworks like LangChain and LlamaIndex, they define an agent at its absolute core as a semi-autonomous piece of software powered by an LLM. You give it a task, and it executes a series of steps by calling tools in a continuous loop until that task is totally complete. The really operative words here are tools and loop. It's not just spitting out a single response, it's actively deciding what to do next based on the results of whatever it just did. Okay, moving right along to part two, workflows versus autonomous agents. This is where we unpacked a really vital architectural divide that the engineering team at Anthropic has pointed out. You see, there is a massive difference between predictable, hard-coded orchestration and true model-driven flexibility. Anthropic notes that we tend to lump a lot of things together as agentic systems, but there's a huge fork in the road. In a workflow, a developer has essentially mapped out the exact code path, right? The AI does step A, then step B, then step C. But in a true agent system, the language model is actually put in the driver's seat. It dynamically directs its own processes. It decides on the fly which tools to use and in exactly what order to achieve its goal. And that brings us to a crucial point from Anthropic's team, which is to only deploy these complex agents when model-driven decision-making is strictly necessary. They call it the golden rule. Literally just find the simplest solution possible. Why? Well, because true autonomous agents trade latency and cost for that better task performance. Every single time the model stops to think, decides to use a tool, reads the output, and thinks again, that takes time. And it burns through compute tokens, which costs money. So if a predefined workflow gets the job done, use it. Save the full autonomous agents for when you truly absolutely need scalable flexibility. Let's dive into part three, the agent harness, and see how this all builds into a complete system by deconstructing the actual software architecture. LangChain actually defines the final agent simply as the model itself, plus this critical piece of infrastructure called the harness. The language model is essentially the brain, right? But a brain without a body or an environment can't exactly do much. The harness is literally everything wrapped around that evaluation loop to make sure the model gets exactly the right context it needs at the exact right moment to successfully complete a given task. These are the precise technical components that give the agent its execution environment, its fault tolerance, and its memory. First up, you have the model itself. Think Claude or a GPT variant. Then you have tools, and these can be anything from simple Python functions all the way up to entire search engines. After that is the system prompt, which is what shapes the agent's personality and its rules of engagement. And finally, you have middleware. Middleware is super fascinating because it manages the agent's context window, which is basically its short-term memory limit. It summarizes past memories so the agent doesn't get totally overwhelmed, and it also applies safety guardrails to intercept restricted data before it even reaches the model. LlamaIndex shows how the agent continuously cycles through this loop right inside the harness. Step 1, the agent evaluates the current state of the task. Step 2, it looks at its available tools and picks the best one for the job, relying entirely on the tool's programming descriptions to know what it actually does. Step 3, it executes the step and observes the result. And Step 4, it judges whether the overarching task is finished. If it is, boom, it delivers the result to you. If not, it loops right back around to Step 1. Okay, part 4, the USB-C of AI. How do these agents actually talk to the outside world? Let's take a look. So the Model Context Protocol, or MCP, solves a massive fragmentation problem. Before this came along, if you wanted your agent to, say, check your Google Calendar, query a local database, and read your Notion workspace, you had to build custom integrations for every single one of those tools. It was a nightmare. MCP is an open source standard that completely unifies how an agent accesses all of this external information. I love this analogy. Just as hardware uses a universal port, AI models now have a standardized connection layer. You don't carry around a different charger for every device you own anymore, right? You just use USB-C. Well, the Model Context Protocol does the exact same thing for artificial intelligence. It perfectly standardizes the connection between the AI application and whatever external systems it needs to talk to. For developers, this is an absolute game changer. It drastically reduces the complexity of giving agents secure, reliable access to enterprise data and APIs. You literally build the server connection once, and it integrates everywhere. Major players across the ecosystem, I'm talking Claude, ChatGPT, development tools like Cursor and VS Code, they are all adopting this protocol. It's rapidly becoming the universal language that lets agents securely step out of their silos and actually take action in our real-world digital workspaces. All right, finally, let's jump into part 5, simulating human behavior. We are leaping into the bleeding edge of emergent multi-agent behavior here, explored in a wildly fascinating joint research study from Stanford and Google. So this paper completely pushed the boundaries by simulating a small town populated entirely by these autonomous generative software agents. The researchers basically created a sandbox environment heavily inspired by the video game The Sims and just dropped 25 generative agents right inside. And to be clear, these weren't standard video game NPCs reading from some hard-coded dialogue tree. These were independent agents powered by large language models, each equipped with the exact kind of architecture we were just talking about. And they weren't executing static scripts either. They followed full, dynamic daily routines. They'd wake up, cook breakfast, head off to work. The artists would paint, the authors would write. Throughout the day, they'd notice each other, form their own opinions, and initiate spontaneous conversations. Then at night, they would actually remember their experiences and reflect on them to plan out their behavior for the very next day. To test how these agents interacted socially, the researchers decided to give a single agent the initial desire to throw a Valentine's Day party. The emergent social behavior that cascaded from that one single prompt was just astonishing. They didn't program any other agent to know about this party, and they didn't even tell the host agent how to organize it. I mean, without any predefined workflows whatsoever, the agents independently planned, socialized, and flawlessly executed the event over 2 simulated days. The original agent organically spread invitations during normal conversations. Other agents heard about it, remembered the details, and actually went out of their way to make new acquaintances just to secure a +1. They autonomously asked each other on dates to the party and then literally coordinated their schedules to make sure they showed up at the exact right time. It was a completely emergent, functioning social ecosystem. Ultimately, the study proved that fusing a language model with a very specific trifecta of architecture is what makes the simulation truly believable. First, observation. The agent has to store a complete record of its experiences in natural language. Second, planning. Using those observations to dynamically decide future behavior rather than just following a script. And crucially, reflection. The ability to synthesize raw memories over time into higher-level, abstract thoughts. That is what creates the illusion of genuine personality and growth. So as we wrap up this explainer, I want to leave you to ponder the massive implications of combining everything we've looked at today. We now know exactly how to build autonomous agents that can plan, reflect, and coordinate complex tasks entirely on their own, right? We saw that in the sandbox simulation. And we now have the Model Context Protocol, that USB-C of AI, which lets these agents directly interface with our actual emails, our databases, our calendars. So what actually happens when a highly capable, multi-agent society gets universal access to our real-world digital lives? It's an absolutely thrilling, totally paradigm-shifting frontier, and honestly, we are just getting started. Thank you so much for joining me on this deep dive, and definitely keep your eyes on the incredible evolution of AI agents.